Giannini, and I'll be the moderator for tonight's debate. In this country, we use about 25,155 terawatt hours of energy per year, giving us the largest energy consumption of any country in the world by about 635 terawatt hours, with China being the closest. That's a lot of energy, and one of the big questions that we're struggling to answer right now as a country is where can we get all of that energy? Tonight we'll be debating on that topic with a specific focus on nuclear energy. The motion is nuclear power is a clean source of electrical energy, and the United States government should provide incentives for the construction of new nuclear plants throughout the United States, including in the Four Corners region. And arguing for the motion, we have Beverly Sandoval, Ken Calderia, and Cole Hawkins. Arguing against the motion are Joanna Lewis and Ashton Cornett. Before we get into the opening statements, I'd like you all to take a moment to vote either for the motion, against the motion, or undecided. Please take a moment to fill out your voting sheet, or for our online audience, pause the video now and click on the link in the description. We will vote again at the end of the debate, and whichever side has changed the most minds during the debate will be declared the winner.
Could you restate the motion, please?
Yeah. It is nuclear power is a clean source of electrical energy, and the United States government should provide incentives for the construction of new nuclear power plants throughout the United States, including in the Four Corners region.
Thank you.
All right. There will be three parts of the debate, and we'll start with opening statements, which we'll get into now. We'll start with Beverly Sandoval arguing for the motion. She has a PhD in nuclear physics from Yale and represents the Scientists Union for Clean Energy. She will be discussing the cleanliness of nuclear power.
Thank you. In 2013, according to the World Nuclear Association, the United States produced 789 kilowatt hours of energy. This is about 20% of the United States' energy use. Coal at 38%, gas at 30%, and wind and hydro at about 12% makes up the rest of the United States' energy usage. Through coal production, the coal is burned to make the power plant function, emitting about 1,514 metric tons of carbon dioxide in 2012. Petroleum and oil prices are on the rise, and our dependence on such energy sources has trapped us in conflicts with foreign countries. Currently, wind, solar, and hydro are green solutions to our energy crisis, but these energy solutions are still highly expensive and have large issues with them. Wind and solar take up thousands of acres of land, but nuclear power plants take up little space. As our environment continues to warm up, the carbon dioxide emissions become a forefront issue, and we are scrambling to find solutions for our high energy demand. Nuclear energy is the feasible answer to our current predicament. Uranium, a resource plentiful in the United States, can be used as a long-term and relatively clean energy source. In 2011, there are about 200,000 tons of recoverable uranium in the United States, according to the World Nuclear Association. We have large quantities of uranium, but the amount required to produce energy is incredibly small. Mined uranium is compacted into pellets which take up little space, meaning little waste is produced. With low quantities of waste, nuclear energy still takes up less space than other energy sources. One pellet produces the same amount of energy as 3 barrels of oil, 17,000 cubic feet of natural gas, or 1 ton of coal. Just one pellet. It's about the size of half of a baby carrot. These pellets are put into power rods that are contained in the core of the nuclear reactor. The radiation that is released from these rods creates an immense amount of heat. This boils water surrounding the core until it turns into steam, which spins turbines to create energy. There is no process that's burning negative material or releasing any emissions. While radiation can be very dangerous if not monitored properly, it is an innovative solution to our current increased demand for energy. When a nuclear reactor is functioning properly, there is little change in the radiation in the environment. Many citizens are concerned with nuclear power plants. But I assure you, all plants operating and following regulations emit an indiscernible amount of radiation into the environment. In fact, we may be exposed to more radiation from natural sources, such as the phone or our cell phones, than from a nuclear power plant that is running correctly. Nuclear reactors have hired resident monitors to live on site of the power plant to constantly monitor the radioactive emissions in the area. They're on site, so as soon as something goes awry, they're taking necessary safety precautions to keep the environment safe. According to the Nuclear Energy Agency, new nuclear power plants will be made with 32% fewer valves, 35% fewer pumps, and 45% less piping than a traditional pressurized water reactor. With less small parts, there will be fewer areas where a mechanism could break, leading to a system shutdown. The control rods in the core determine the amount of heat the reactor produces. At Fukushima, the tsunami wiped out the power plant and wiped out all of the controls in the power plant center, and so the rods couldn't be moved, causing the core to overheat and melt down. However, new power plants will be built with a safety feature that is designed to have the control rods drop no matter what. New plants will be designed to have electromagnetic forces holding up the control rods, so when the electricity gets shut off, the rods will drop automatically and stop the nuclear fission reactions. The United States needs a reliable, clean source of energy as we move forward and demand increases. Nuclear energy is a clean source that should be promoted and expanded in the future years of our energy-dependent country.
Thank you. Next up, we have Joanna Lewis, a representative of the Worldwide Association for a Clean Future. She is an environmental engineer who has extensively studied nuclear waste and waste management. She is speaking against the motion.
Good evening. Nuclear energy is clean? Really? What about the almost 3,000 tons of spent nuclear fuel created each year in the US alone? Is that clean? While this amount of waste may be low compared to other energy industries, it is highly radioactive. And according to the World Nuclear Association, none of this waste can be recycled or reprocessed in the United States. So here we have this energy industry that my opponents are trying to expand into our region. This is an industry that produces radioactive waste that will remain on this planet for up to over 500 million years, emitting alpha, beta, and gamma radiation, and is relying solely on direct disposal. The nuclear power industry is the only energy industry that takes full responsibility for waste management, but it has resorted to using a disposal system that is still experimental. The Waste Isolation Pilot Plant, WIPP, is the only high-level waste disposal facility in the United States. However, it is continually prone to accident. In February 2014 at WIPP, which is located near Carlsbad, New Mexico, there were 2 accidents in 1 month. One occurred when an excavation truck caught on fire and caused 6 workers to be treated for smoke inhalation. The other accident was so severe that the plant, 3 months later, has yet to reopen. There was a radiation leak that not only contaminated dozens of workers, but also emitted radioactive dust into the surrounding environment. Both incidents are still being investigated, and there is no explanation to the cause of either accident. WIPP said there are currently too many unknowns to provide a date for receiving waste again, indicating that they are incompetent in even identifying existing past and latent threats. These accidents not only show the inevitable hazards to workers and the surrounding environment that accompanies storing radioactive waste as a subsidiary of nuclear power production, but also highlights the uncertainty and lack of responsibility that comes with pursuing nuclear power. The fact that we exclusively store potentially fatal nuclear waste in a facility identifying themselves, quote, as a science laboratory, and are unable to pinpoint the cause of accidents, shows that we do not have enough knowledge of the field my opponents are trying to promote to safely, responsibly, and knowledgeably expand this dangerous industry throughout the United States and into the Four Corners area. Thank you.
Thanks. And we will now hear Ken Calderia's perspective. He is an atmospheric scientist from the Carnegie Institution for Science's Department of Global Ecology and will be speaking for the motion.
I know many of us understand the consequences and costs of CO2 emissions that are having global effects on our atmosphere. I would like to emphasize the urgency and seriousness of this situation. This is a problem that is happening now and needs to be dealt with now. The best current solution to this problem is nuclear energy. We cannot sit around waiting for future generations to come up with other solutions while the threat of global climate change is very apparent. And at this moment, nuclear power is our best option. Since we adopted the use of fossil fuels, the amount of CO2 that is being emitted into the atmosphere has greatly increased. From prehistoric air bubbles found in ice core samples from sites all over around the world showed the amount of CO2 varied at levels that never gone above 300 parts per million. But atmosphere tests today show that it is more than 400 parts per million in 2012. And every day the number is growing, causing more heat from the Earth's surface to be absorbed and increase the temperature of the Earth. CO2 is a naturally occurring greenhouse gas on this Earth and is part of our system, which is essential for life on Earth. But if we have too much of one thing, that's where the problems start to occur. Nuclear power does not emit any CO2 into the atmosphere, and is a clean energy source. If we do not act now and start relying on nuclear energy, by 2100 the expected overall temperature is expected to rise by 5 degrees due to the increased CO2 emissions. Because of this increased temperature, ice caps will melt and cause the sea level to rise. The expected amount of sea is supposed to raise around 20 centimeters to 60 centimeters, which will displace millions of people living near sea level. The countries that will be most affected will be low-lying countries like Bangladesh, costing billions of dollars. I hope I express the urgency of this situation at hand and urge you to consider nuclear energy as the best current option to stop relying on fossil fuels that continue to release CO2 into the atmosphere each year. Even if nuclear energy has some risks, they can be mitigated and monitored. I ask that we look at nuclear energy as a stepping stone for other sources of energy that could be safer and just as efficient. The future is at risk, and we must act now. Thank you.
Thank you, Mr. Calderia. Next we have Ashton Cornett, who has researched the effects of uranium mining, and he will be speaking against the motion.
Okay, I'm here to talk to you about the mining, milling, and enriching of uranium. When we go mining, we're doing in situ leaching, which is taking a sulfuric acid and pumping it into the ground mixed with water, which is melting down the uranium and sucking back up. This is being done below and above aquifers. If that breaks through into the aquifers, all that water is ruined and it's been contaminated by acids, which cannot be moved easily, which will cause a lot of money to redo. With the milling, we are creating there's so much money put into creating this and enriching it. With enriching, the whole process of enriching, mining, and milling is creating CO2 emissions. The nuclear power itself may not have it, but the enriching will. Annually, it creates about 27,200 tonnes of CO2 emissions, which is about 2,204.6 pounds a tonnes, which is a lot of CO2 emissions annually, which shows it isn't all that clean. The process of getting it is ruining everything compared to having the nuclear power, which is the cleaner part of it. So this power is causing more damage to get it than it is to help us. I feel that we need to shoot down all these corporations' ideas for the uranium mining and make it cleaner and stay without it. Thank you.
All right, and we will conclude our opening statements with Cole Hawkins, who is an expert on nuclear energy and waste.
Thank you. If we don't start using renewable energy now, then we may never make the switch. So this is the chance to take the first step. Some scientists and industry experts look towards international fast reactors, the solution to the problem of nuclear waste. In these plants, uranium and plutonium are separated or reprocessed, and this is a spent fuel is then used to power the reactors. Processing eliminates nuclear waste. It doesn't eliminate the nuclear waste, but it does reduce the volume and the toxicity. The waste has a much shorter half-life, instead of hundreds rather than thousands of years. Safety measures include a passive system, doesn't require a human reactor to shut down that operation, so it's actually safer for the plant if someone doesn't have to be there and there is human error. In this case of a malfunction. Of nuclear power, often measured in economic power, is kilowatts. Nuclear power plants produce more kilowatts than coal, wind, solar, of fewer cents per unit. As more plants are built, it's expected that construction costs will come down, making the price of nuclear generation electricity that much more attractive. The construction comes from jobs. So something fewer could make a case against the current economic climate. Existing and further nuclear waste can be reduced through waste recycling and reprocessing. Nuclear energy is ready to be forefront and renewable energy source. In fact, we can produce 100% of our energy from renewable energy by 2050. And the technology is ready for the market, particularly if the substance of fossil fuel is kept from the earth.
All right, thank you. At this time, we will enter into open debate, during which the audience is encouraged to ask questions, either to specific debaters or of the group as a whole. Please keep your questions relevant to the debate. Debaters can also ask questions of other debaters. So far, those supporting the motion have pointed out that nuclear energy is clean, produces small amounts of waste compared to other energy sources, and can recycle fuel to limit waste. While the opposing side has raised concerns about waste storage, aquifer contamination, and emissions during the mining process. I'll start out with a quick question. During your opening statement, Ms. Lewis, you said that no waste can be recycled in the U.S. No fuel can be recycled in the U.S. But Mr. Hawkins said that some plants are recycling fuel to reduce waste. So, could you speak on that for a moment, please?
Yes, according to the WNA, or the World Nuclear Association, the United States cannot recycle or reprocess any of their spent nuclear fuel, which is about 95% uranium-238, which could potentially be converted into another isotope of uranium-236, which could be used for nuclear reactions. However, the United States cannot recycle this fuel, and so many other countries, Switzerland can, and a lot of other European countries using nuclear power can recycle their spent nuclear fuel. However, the United States cannot.
So, if the United States can't recycle it right now, but we're in favor of the motion of starting new nuclear power plants and trying to make this something that the United States is working a lot on new technologies for and working on developing deeply in the United States, why wouldn't we be able to develop those if the other states are doing it? That would eliminate the waste. That would also allow for reprocessing, which equates to more energy.
It is possible that we could potentially harness this ability to recycle our waste. However, as several of your debaters have mentioned, we are ready for nuclear power production now, and the technology is ready, which if we are not being able to recycle our waste, clearly the technology is not ready.
If you did recycle, you can explain the chemistry of this to me a little bit. If you did recycle spent fuel, is that what we're talking about?
Yeah.
Wouldn't you still be generating radioactive waste?
Yes, you would.
You would be generating radioactive waste. However, the radioactive waste that you would be generating slowly is turned into a shorter half-life. And so Joanna Lewis was speaking about how when we have spent uranium, the half-life of that is, she quoted 500 million years on this earth, and we don't know the effects and the lasting effects of that. However, the more times we put that uranium, or put whatever is decayed after the uranium has been spent, whenever we put that into a new reactor, the half-life is decreased, which means that it's less time on this earth. Additionally, I'd like to add that after it's been processed, even after it's been processed and it's been put into a waste facility, it can be taken out of that waste facility and reprocessed. So right now, if we're developing that technology to design nuclear reactors that can reprocess, we would be able to use the waste that we already have to put into those reprocessing facilities.
I would like to add also the fuel rods that we use, 95% of that fuel rod is still reusable. And going off of how they can shorten the half-life of the nuclear waste, there's actually research being done where they've been shooting protons at nuclear waste, and it apparently decreases the half-life by half.
The question to you is, what are you going to do with all the plutonium that's created from reprocessing, which is weapons grade?
The plutonium can be reprocessed as well.
It's going to create more plutonium. We're going to have all this weapons grade. Everyone's going to look at us like we're creating weapons grade material, like we're transplanting for something.
The plutonium can be reprocessed and turned into americium, which has a half-life of 7,370 years, as opposed to the half-life of plutonium, which has a half-life of 24,100 years.
I think the point that my colleague is bringing up is that when we are enriching uranium, whether it be for power usage or for weapons, by enriching more uranium, even if it is for nuclear power, we are enriching more uranium that could potentially be used for weapons purposes.
But also that's a higher grade uranium, so we could actually use more of that energy.
Plus, we are trading uranium from Russia that was used for nuclear weapons for nuclear energy.
All right, in the audience have questions?
Why is it that we can't recycle the waste? I mean, if other countries are doing it successfully, what prevents us from doing it?
I don't know, the technology just hasn't been implemented yet into our system.
It's similar to what Ashton was saying, that we're scared that we're going to look like a country that's trying to develop more nuclear weapons, because when we reprocess it, he's right, plutonium is what we get left.
Plutonium is created just through nuclear reactions, though 1% of all nuclear waste is plutonium.
Right, and so if we're trying to use that in nuclear processes instead of just disposing of it, that may be what we're scared of.
Anybody tell me how long it took to build the Seabrook nuclear plant in New Hampshire, Massachusetts, or New Hampshire? You know how many years it took? Anybody take a guess?
25 years?
No, but it took a lot. It shut down because of many construction problems and finance problems, including problems. And also there was some union problems, etc. But these things don't come online very quickly. So you're talking minimum 5 years. If everything went on, 10 years, a dozen. And then you've got, if you stop construction and for instance, a union dispute, that walks off the job, then you got what they call cold connections when you pour the concrete. And that weakens the vessels. So there's a lot of thought and a lot of effort that has to go into it. It's not a quick fix. And the other question I have, France, I think, is the largest nuclear country in the world. What do they do with their waste? Where does it go?
They're renewing it. They are actually one of the countries that has the technology to renew it. And I was going to go off the point that by 2050 we can have all our energy 100% nuclear power.
But do we want to have all our energy nuclear power? Then we are putting all of our energy needs into a system that could potentially melt down at any moment, causing fatal health problems to the population.
I would like to say that right now we're pretty much relying on fossil fuels, and if we continue to do so, like I said in my opening statement, things are going to get bad. And if nuclear energy is the most efficient source of energy we have, there are other sources of energy like wind and solar, but those don't always work all the time. There's not always wind or there's not always sun. And those will not fit the demands of our civilization. So that's why we need nuclear energy, because it's efficient.
There's not always going to be uranium here.
No, but there's a lot more uranium currently in the United States than we have fossil fuels, and it's an efficient and clean source of energy, which means that it's not producing any carbon dioxide into the air. If we continue at this rate, the environment could increase by 2%, which would have drastic effects on the environment and our entire atmosphere.
Yes.
Question your assertion that we have more nuclear energy than we do fossil fuels.
We have more uranium than we have fossil fuels in the United States, pardon me.
And how do you calculate that?
I don't have specific numbers, but I do know that we have, if the uranium that we have on the Earth now, it has a half-life of about what the Earth's lifespan is, then we're only halfway through our uranium, and so we still have that much more time of that uranium left on the Earth.
That's my question.
Yes.
Can I just make a comment?
Yeah.
I just think it's ironic that you're saying we should move from one finite resource, so fossil fuels, to another finite resource, instead of using these completely renewable resources like wind and solar that you guys have totally written off. And Andy said there's not always wind and there's not always sun. Well, yes, there is always wind and there is always sun somewhere. And I think if you looked into the amount of energy that we could produce with, say, solar energy, with kind of in regards to the amount of just like sun that the Earth gets in 24 hours, it's a huge amount, especially considering the advances that have been made in like solar technology. I think in like the past several years, they've made huge improvements to their technology, and so I just think that's
Yes.
interesting.
But right now, those energy sources are very expensive, and the average person can't afford to get wind or solar. So if we go to nuclear energy, we could use it for a stepping stone for another source of energy like fusion, which nuclear energy splits an atom into two smaller atoms, while fusion takes two atoms and puts them together. And the cool thing about fusion energy is you use hydrogen atoms, and that is the most abundant thing on Earth, and we will never run out of it, since you're essentially taking the hydrogen atom out of water and using it for energy. But right now we are not quite to that point where we can go on to fusion. So if we turn over to nuclear for that sum of time until we get advanced enough to move on to fusion, I think that's the way we should go, because fossil fuels are doing so much damage to the Earth, and we need to stop using them.
I think that's an interesting point, but I'd like to point out that our topic is not questioning whether we should use renewable resources or not, but rather whether we should have government subsidies for nuclear power. So I'm going to bring us back to that, the question about water usage. So in the Four Corners area, we're very limited for water since we are in the desert. So what kind of water usage are we going to see with nuclear power plants?
I can answer that. Only 40% of United States power plants recirculate their water. So power plants is a cooling rod system enclosed in a big tank, basically, and they pump water through the fuel rods to cool them off, not actually through them, around them, to cool them off, and then they have to take that water that's now been heated up by the fuel rods and cool them up with other water. So this is a very water-intensive process, and only 40% of United States nuclear power plants are recirculating their water, and those plants are still withdrawing 600 to 800 gallons of water per kilowatt hour of electricity that is being produced. This is according to the Union of Concerned Scientists. And the 46% of nuclear power plants that do not, that do recirculate their water, are withdrawing 25,000 to 60,000 gallons of water per kilowatt hour of electricity. Also, spent nuclear fuel, before it can be transported to either a deep geologic respiratory or dry cask storage, has to be placed in giant pools where it can cool and emit a lot of its radiation before it is taken to other storage facilities. So those pools are also utilizing a lot of water. So the answer, Four Corners area, we don't have a lot of water, and this is a very water-intensive system.
I would like to point out that oftentimes in nuclear reactors, salt water can be used, as well as dry cooling systems, which means that they don't use any water in their cooling system. And then the other thing that scientists are starting to develop as new technologies come out is breeder reactors, which actually uses metal, so liquid metals, that might be sodium or your mercury, as a cooling system, which doesn't provide any water usage.
Dry cooling systems do not function in the United States. We have not yet developed that technology either. And we don't have access to salt water in the Four Corners. And Colorado is the only state that has, one of two states that all our water runs out of it, so we would be using our fresh drinking water for cooling.
We actually do have a lot of saline groundwater.
We don't have salt ocean water.
So we wouldn't have to build one in Colorado for that reason. It's not like we're having to choose
Well, our
No,
motion is
but
regarding
yeah.
power plant development in the Four Corners area.
Yeah. All right.
Utah, Arizona,
So,
and
thank you all, but we're out of time for open debate. So, going to move on into closing statements, and we'll start with Cole Hawkins.
If there is no nuclear power, we will have to manage as well as possible. But as a force of major argument, we must have some kind of power. So if we're not using nuclear and we don't want to use fossil fuels, what are we going to use? Because we do not have the technology to have wind power or sun power to power our entire city. And if nuclear power, we can use that for a lot of kilowatts. And the most, before you say not to try and accept this, when is all this said and done? The claim that nuclear power is more cost effective and that we really need to think about if we're taking the time to build nuclear power reactors now, then why not just make the switch and use our energy and wisely and switch to nuclear. And like wind or solar, coal, and does not stop, like solar and coal, it will eventually, coal will stop working, like we'll run out of coal eventually, and it's putting out a lot of CO2. And with wind, like, what if it gets cloudy?
All right. Thank you, Mr. Hawkins. We'll now hear Ashton Cornett's closing statement.
Okay, preventing nuclear power has so many good things to come from it. There would be less debris coming and destruction coming from the mining of the uranium. We'd have so much more money. These take billions of dollars to create these nuclear reactors. It takes so much time to make them. We'd be better off putting more money into research for better wind and solar powers than putting all of our money into the nuclear. Yeah. Also, we wouldn't have to worry about recrossing issues. We wouldn't have to worry about so many more different things. We wouldn't have to worry about meltdowns. Everyone's worried about these meltdowns that could happen anytime. Natural disasters could happen. Man-made errors can happen. I feel without these nuclear reactors around, everything would be so much safer and nicer and cleaner around.
All right. Thanks, Ashton. We will now next we have Ken Calderia.
There's no arguing that there are risks with nuclear energy. There's a problem with nuclear waste storage, which can be safely maintained and monitored. Having radioactive material that lasts for thousands of years and is very harmful. But like I said before, there are ways to shorten the half-life of these radioactive materials by half. There are risks of nuclear meltdowns, having surroundings areas unlivable like Chernobyl and 3 Mile Island. But I would like to add that there's only been 3 major accidents over the last 50 years. And comparing it to fossil fuels, there's been a lot more accidents regarding that sort of field. And these disasters are lesson learned, and we now have new and better technology that could safely monitor and mitigate these risks. These issues regarding climate change must be solved today. And even if we solely depend on nuclear energy, we can move forward exploring new energy like fusion. All risks can be mitigated and monitored, and we can live safely on this earth. If we continue to rely on coal, oil, and gas, we will be dealing with mass extinctions not only of other species, but of our own species. Thank you.
All right, thank you, Mr. Calderia. Now, with the last word for the opposing side, Joanna Lewis.
So I had a nice spiel prepared about the half-life of uranium-238. However, one of my colleagues was unable to make it today, and I would like to highlight some of the points that she was going to make about nuclear meltdowns, which, as Ken just highlighted, there have only been 3 nuclear meltdowns in our current nuclear power history. However, increasing the number of reactors worldwide in the United States in our area would increase our potential for having meltdowns. So at the Chernobyl meltdown, a radiation cloud killed over 10 square kilometers of forest, dubbing it now the Red Forest. It also increased DNA mutations 7-fold in children born after the Chernobyl accident. This meltdown also, radiation that escaped during this meltdown, also decreased the size of bird brains in the area, increased oxidative stress, and decreased antioxidants in species. It has decreased the total invertebrate population, including that of pollinators, which are vital to ecosystems. And I think that's one of the important things, is that we are, by pursuing nuclear power and the potential for radiation being contaminated into our environment, we are putting many species at risk. And this is a industry that will create waste that will be on our planet for, as the half-life of uranium-238 is, 446 million years. That's a very long time. Humans aren't going to be around that long, and our waste still will be. So, is nuclear waste the legacy you want for our species? Vote against the motion if you agree. Alpha particles aren't all the future's cracked up to be.
All right, and to conclude our debate tonight, we'll hear Beverly Sandoval's closing statement.
As a country, our energy consumption has trapped us in a cycle of troubleshooting and rethinking our methods. We have found that producing non-renewable resources not only means abusing a resource that makes us depend on foreign countries, it also means releasing many toxins into the air. We have found that renewable resources are difficult to harness alone and cannot sustain our energy-hungry country. We have found that nuclear energy produces masses of energy from small amounts of uranium, and the production is clean for the air and the surrounding environment. Nuclear energy is safe and has increased, and now reactors are being built with special precautions to protect the reactor from a meltdown. Nuclear energy fuel, uranium, is domestically found and can be mined and produced within our country, eliminating our dependence on foreign resources. Nuclear energy is the obvious choice for clean energy. Vote in favor of the motion and help nuclear energy become our future.
Thank you, Ms. Sandoval. That concludes our debate for this evening. This time I'd like you all to consider what you've heard and then re-vote by filling out the bottom portion of your voting sheet. For those of you watching online, fill out the bottom part of the survey linked in the video description and submit it. Remember that your vote determines the winner of the debate, so consider it carefully. Thank you for your attention, and thanks for attending tonight's debate.
Yay!
There's a box by the door.